the entire kind of architecture is one challenge that you actually want to, when you actually want to use the AI in the real world. And to support such software-defined or cloud-native environment, you need to do a lot. So AI is just one functions of autonomous driving, which is of course the main functions, but in order to optimize the AI capabilities, you have to create development and operation framework. AI must be always tested. The geometry informations also always need to be aligned with AI, and somebody has to manage or monitor if AI behaves in the right way. And sometimes you want to update the AI capabilities, so you need to collect data to retrain AI models to be better. So these cycles, which is often called DevOps, is a really complex undertaking for most of the companies to deploy. So it's a challenge. The AI is mature, but the environment to support AI is still a work in progress. Also, AI means a lot. When people say AI, which is often referred to the AI model, but AI needs to be trained. And this training framework is also quite complicated. This workflow just demonstrates an example of the system that my startup is supporting. Looking at different kind of phases, using many tools, need different data storages, and also many pieces of additional software platforms will be required, like machine learning, kind of data annotation. CI/CD is something, it's a test environment that ensures AI is always right. These details, most of kind of AD autonomous driving expert are kind of struggling to establish because sometimes you need to talk to multiple stakeholders. So I would say this is also getting more commoditized. But right this moment, the challenge for the AI for autonomous driving is not actually AI model itself. It's more like a environment to train the AI and keep AI always right. It's kind of challenging topic. In particular, recently people found that kind of domain adaptation kind of significant challenges. What is domain adaptation? So domain adaptation is that one AI model trained in some environment, imagine that it's in Japan, can be transformed to and optimized for Chinese environment without retraining the AI model using the local data. Because collecting data in the local place needs time. So people want to save time, save cost. So domain adaptation is that AI model trained in some place can be transformed, optimized for another place so that without domain adaptation, of course, because the AI is not trained, sometimes object detection may fail. But with domain adaptation, it is expected that it can always detect objects in a correct way, right way. So these domain adaptations, so one of kind of even kind of research challenges in autonomous driving domains, and we also trying to support the software that can ease the deployment of domain adaptation, but still work in progress. That being said, domain adaptation is getting more and more useful. So this video shows multiple applications of autonomous driving using the same software, the same hardware, without retraining the AI models using domain adaptation. So this is robotaxi. It's one of technology symbol that people often imagine for the autonomous driving. And this is autonomous shuttle. It's the same autonomous driving, but with a different hardware. And sometimes the similar hardware kind of between the bus types can be also kind of deployed in a different place. These kind of wide application support. So this is kind of airport use case. So again, they are all the same, all the case, the same software, hardware, and using the same AI model without retraining the local data. So in the different countries, different types of the vehicles and different types of use cases, even autonomous driving sometimes be useful to support factory automation and probably small robot delivery and more entertainment stuff. They are not demos. They all already deployed in real world, 24 hours, 365 days operation. But still, we need to improve kind of development operation cost. So in addition to kind of software technologies, we also need high quality hardware. The camera may be most straightforward example. Say AI may not work if the camera doesn't give you the right input. So typical machine vision cameras are struggling with reverse the range of focus or angles of the field view and some very detailed parameter configuration to be kind of adjusted for kind of traffic light or just vehicle or pedestrian detections. And recently, not only camera, but also other active sensors like a laser scanner or radar, mid-wave radar. So you want to use them together. This is called sensor fusion. So these types of kind of new hardware can also support better AI, but again, you need more effort. Finally, testing of AI for autonomous driving is one of the largest challenges. So this is called one of kind of interesting solutions to test AI is a digital twin. So this digital twin means kind of copy of the real world. So this computer graphics is actually generated from Tokyo environment and exactly the same asset like trees, buildings, statics of cars and pedestrians. And you can also say add more combinations of scenarios so that this is useful because you don't have to test AI in the real world. You can generate this digital twin cyber space in a server, then just doing the test 24 hours can accelerate the testing of AI. So this is example. So left-hand side is digital twin given to the system, and right-hand side is the AI system. AI system doesn't know if the given environment is the fake digital twin. So it can recognize cars, pedestrians as if it runs in a real world. This is really important because in the real world, testing AI still takes some risk or time but using digital twin, you can test 1,000 use cases before you actually go to the real world load test. Lastly, and even using digital twin, or I would say simulation, there are thousands of test cases that you have to go through. And you don't want to go through 1,000 test cases because it takes time, money, cost. AI can actually help to make the test efficient. So this example, I skipped the details, but it tells that red points are those that you want to test. And if you don't use AI, you may need to do the whole red point test. But if being told by AI, don't test the whole test cases, just pick one test case, then resolve some bug, then the test cases can dramatically reduce. The AI can tell you the orders of the test cases. Don't test from 1 to 3, 4, 5. Just skip 1 to 3 and go to the number 5 test case, then the other test cases can be reduced. This is often called defect proneness. So AI can tell you the most efficient steps to test actually AI models. So we had some kind of research results, and it can dramatically reduce the number of test cases that you have to do. So we are still kind of work in progress, but these types of pieces of technologies, all you can get by open source. So you don't have to build what I explained today. You can leverage open source, then start building your system or platform or services on top of open source. Will enable as many organizations or individuals as possible to be part of this ecosystem. And as a result, the technology will be more advanced. And now most of the countries start making rules to accept AI for autonomous driving. In Japan, officially now it is permitted for driverless car to be operated on a public road. So having technology and test schemes will also allow the government to say yes to start deploying autonomous driving. So we are very excited to have the technology to be deployed in all over the world very soon. Thank you.
Many thanks, Kato Shinpei, for this very nice presentation on the impact AI has on autonomous driving and the role open source and platforms have in this respect, and the insight in your work of progress on the model training and domain adaptation. I especially like the use of the digital twins in future to save time. Thank you very much. Now it's time to give the floor to Luis George Romero from Etsy. He has a time conflict to join, so we deliver his pre-recorded video. Let's welcome him. Please start the video.
Hello, everybody. I'm here today. I'm Luis Romero from Etsy. I'd like to thank again the organizers of this GIO Roundtable for having me and having Etsy here. It's the 12th meeting that we are having, and I apologize because I would have liked to be with you. The commitments drive me a little bit away from you. Today, the topic I've been given to speak about is AI for telecommunication, and it's a huge, huge topic. But on the other side, I know that we want to have some more concrete approach to it. We want to have our own experience and knowledge. And here's when I started thinking of knowledge and me and AI, I thought, what I'm doing here. But anyway, I have to share a little bit experiences from the standardization perspective, and also try to see where we are at with AI in telecommunication, specifically in Etsy. So, and definitely it's very complicated because AI is very, very broad. So I'll try to put a little bit of focus. We know that this term of artificial intelligence, AI, has been either too poorly defined, either too widely defined. At the end of the day, what we already know is that there are many organizations putting focus on AI, trying to make a good definition, which is great. However, because AI is such a vast field and it's involving such a wide variety of expertise, of differences, we in ETSI have tried to have a little bit more focused approach. We understand that AI is not an end goal, at least for us. It's much more a means to achieve this goal. So that's why we've taken this as we call distributed approach to AI. And we see the role of AI a little bit more of a means of enhanced machine-enabled decision-making that has and is being at the heart of many of the ETSI technical groups. So we are looking at AI as a means to achieve these goals and to derive insights. So based on an evolving set of statistical data and learning, try and pull out methods of decision making. They help us final goal, which is, I would say, getting this more flexible, accessible, dynamic, ubiquitous, you name it, networks, because we're talking about telecoms, and that's what we are trying to get with AI. One of the case studies, the typical example has to do with autonomous networks, where we seek self-configuration, we seek self-healing, self-optimization, self-protection, also self-awareness and self-knowledge. So there's a lot that we are bringing inside the network to enable and promote its capabilities. And at the end of the day, it's not about getting rid of people. No, it's not about pushing people aside, but on the contrary, trying to augment all these human decision-making and action processes where AI could be a catalyzer, AI could be a huge enabler. When I talk all about these building blocks, about tools, what do I really mean? And by that, I would like to really focus on what we are doing in ETSI. Some of our technical groups which are actually focusing and looking at AI. I will not go through all these groups I've listed, and in fact, there are many more in ETSI which are devoting some time and are taking AI as central. But I would nonetheless like to highlight some very specific examples. So on one side, if we start with, I guess, one of the precursors, CINT, which stands for Core Network and Interoperability Testing, defined some time ago this GANA framework. So GANA stands for Generic Autonomic Network Architecture. There's a role of AI techniques for autonomic management and control, and for self-management and self-configuration of the networks. So there's a place where we see that in the definition of specification, AI is taking an important role. Then we may go further on to IGENI. So this one stands for Experiential Network Intelligence. And this group has defined the generic, the architecture that uses AI and other mechanisms in order to improve its understanding of the environment. And hence, with this understanding, helping the operator and improving the operator's experience with the network. Again, another very clear and direct application of AI into solving problems of our networks day to day. Next group I would like to put some words about is ZSM, so Zero Touch Network and Service Management. Because ZSM is defining this end-to-end architecture for network automation, where networks should be able of self-configuration, self-monitoring, self-healing, and self-optimization without human intervention. So this would require an architecture that's designed to enable closed-loop automation, and also that is optimized for data-driven machine learning, and also for artificial intelligence algorithms.